Thank you, guys. Let's start. First of all, good afternoon, Pythoners. My name is really Niko Skrypnik, and I'm talking about 2D, 3D graphics with Python on mobile platforms today. And when we hear it, 2D, 3D graphics, we usually think about some games, but also it may be not only the game, but some other applications which use the graphics intensively, like for educational purposes, or I don't know, some for probably 3D viewer, for example, for engineer, which may show some design and stuff, or something like that. So, and when we consider the using Python for developing some graphic stuff for mobile platforms like Android or iOS, first the question which may rise in our minds is why? So why really we should use the Python, as there are a lot of existing tools like Unity or many other game engines which allows you to do the same, just to develop the game, and it will be cross-platform. You may do it both for Android and iOS. Well, I even have the answers for this question, and first it's just for fun. Yeah, so we love Python. Many of us are hobbies who just make the games for hobby, and it's very cool really when you develop something on the Python and you may run it on your favorite mobile phone or your iPad and whatever, and you may do, for example, right now there are some games, the clone of the games like a clone of the Flappy Birds, which is written on the Python, and you may find it on the Google Play Store. And the second reason is the educational purposes, because as we all know, the Python is a very good language for educational purposes. It's very easy to learn, especially for kids, and also the OpenGL, which is quite, well, maybe it's just me, but I think that it's quite non-trivial stuff. And with Python, for example, it's easier to learn it because you are concentrating on the learning the OpenGL concepts, not on the building and debugging the C++ code instead. So really, it may be used for learning by kids, for example, the using of OpenGL and creating the graphic applications, which may be launched on the mobile platforms. And second question, which may rise in our heads, is how? How can we do it? So fortunately, we have the Kiwi project, which was mentioned by Guido van Rossum today. And well, it's the framework, or rather it's the project, which includes a lot of frameworks and tools which helps you to create the cross-platform application with Python for different platforms. It includes such tools like Python for Android, which allows you to create the APK package for Android, or Kiwi iOS, which allows you to create the whatever it's called, the package for iPad. And so what's the Kiwi just provides for us, we may use for our goals. First of all, it provides us the ported Python core, which is the Python interpreter, which is ported for any platform like IRM specific for Android or iOS, so you may just run it and run any Python code. And also, it provides the wrappers around the OpenGL functions. Well, rather the OpenGL ES functions, because you know OpenGL ES, it's the subset of the OpenGL for embedded systems, which are the mobile platforms as well. So we have the Python interpreter, we have the wrappers of OpenGL functions. So in general, that's all what you need to make graphical applications if you're proficient with OpenGL. And well, I may just finish my talk here, but I'll continue further, and I'll explain which another abstractions may Kiwi provide to, you know, make your life a bit easier if you want to do some like game with Kiwi. So first of all, yeah, it's just window, which is the class which represents the screen of the device, of the mobile device, the whole screen, and this whole screen is also the canvas, which you may use for drawing anything you want on this canvas. And also, as many other GUI libraries, it provides the concept of widget, and each widget may its own canvas. You may also draw something on this canvas, and it's maybe nested. It may has its own size, position, so you may locate it anywhere you want on the screen of the mobile device and draw anything you want. So, okay, sorry. We have right now the widget, the canvas, and all other things you may need are located here in the graphics module of the Kiwi, which is written on the site, and so it may work quite fast for drawing all the graphics. And the main concept of the drawing something with the Kiwi is instruction. Which may be, well, the two main kinds of instruction exist in Kiwi. It's the vertex instruction and context instructions. And let me explain the difference between them. The vertex instructions is something very easy. It's just the graphical primitives you may use for drawing some rectangle, circle, quad, line, and from these primitives, sure, you may create some more complex image in your application. And at the same time, context instructions is something not visible really, but it may impact of how the other graphical primitives may be drawn. So it's the color, so you may just set the color of the graphical primitives which may be drawn further, just rotate, scale, translate, bin texture, whatever you want to do with this. And let's look how it works in the Kiwi. And in the Kiwi, as I already mentioned, we are working with the canvas. And we just need to specify the list of the instructions for each canvas, which will be executed while the canvas will be redrawn. So with the with statement, we can easily specify the number of instructions like color, rectangle, color, again, ellipse, whatever you want. And it will be drawn in this, in this canvas. And also, alternatively, you may just add it via the add function to the canvas. And yeah, there are some properties of these instructions, like position, side for rectangle, which you may change dynamically in your application, and it will be redrawn, because each time you are changing the property of some of the instructions, it's triggered the redrawing of the canvas. So you may just change it, the size of the rectangle somewhere in the application, and it will be redrawn immediately. So yeah, sure, you may just store the instruction to some variable and then use it further in your application. And the canvas is just list. So as I already said, you may specify the number of the instructions, and they will be executed in the sequence you just set. So dynamically, you just may change something, and just change whatever you want in the canvas during the execution of the program, which may be used. So okay, let's just show a small demo. For the primitives, it doesn't work very fast, unfortunately, via the USB, but here's the simple application I run just on the Android, and here's the just circle, rectangle, and triangle, which I drawn with using of Kiwi. And sure, it may be not very interesting if you don't use the textures. And using the textures with Kiwi also extremely easy, because you just need to load the image with the image class and get the texture from it, and set for example, rectangle in structure. For any vertex in structure, you may set the texture, and you'll get something like 1 second. Let's launch application again. Okay, you may see something like this. So in this way, you may really create any 2D application, like game, um, and like in this small game, I just bound all the graphical stuff to the SciMunk, which is the port of the Chipmunk physical engine. And you may, I'm sorry, it probably works. Not because the key is slow, it's because the USB is slow. Okay, so yeah, something like this you may create also with the Kiwi. But let's return to my presentation. So yeah, here's the question: where is the OpenGL then? If I just show you a lot of graphical primitives, and as I already said, you may use all the functions of OpenGL, but no, it's not here. It may be used with the special instructions which called callback. And each time when you place the callback inside of your canvas function, well, it's just call it back each time the canvas is redrawn. So you may place any GL function, like for example, I here placed the GL enable GL depth test function in my callback, and then it will be called each time when the canvas actually redrawn. So in this way, if you are proficient with the OpenGL, you may create anything you want inside of callback. But also, as I mentioned here, just reset context equals to true. It's very important to do because you may, for example, break all other stuff which should be redrawn after your canvas. So reset context just reset actually context to the initial state before all your OpenGL instructions was made. And it will be very useful if you don't want to crash something in your application. So yes, really, just I mentioned about the enabling the GL depth test by default. In the Kiwi, it's not enabled. But if you want to do something like this, you really need to use enable depth render buffer to be able to do something like 3D stuff. And let me show very quickly how it may be done with using of Kiwi. So Kiwi provides you the render context class, which is the special canvas which may store all the variables, which is actually maybe the uniform variables for your shader. I hope that someone here know what is the shader is. Here's how it may be used. So first of all, you just need to create and override the canvas of the widget to tell that I really want to use the render context instead of usual canvas. Then we need to specify the path to the shader file, or either the text of the shape vertex of fragment shaders itself. As on the third section, I show how you may easily set the uniform variables just to set the color, which is red here, and some other variables like model view matrix. And sure, the application in simplify view may looks like this. So you are just enabling first the GL depth, then well, you quit your canvas, you should disable it, sure. And inside of it, well, it's maybe a good idea to push the matrix, because if you change the global matrix, you may again break something in your application. And in the some vertex instructions placed here, you may just place some your vertex instructions like mesh, for example, where you may specify vertices, indices, like it's like OpenGL concept. And also you should specify the format FMT, the format of the attribute variables which will be used in the shader, and I will show you here. If you see, I'm specifying the vpos, vnormal, and vtc0, and then I use, well, not the vtc0, but on the first two as the attribute variables in my shader. So in this way, you may just create any mesh you want and draw any shader you want to change. Well, yeah, to do generally whatever. Okay, and in the end, you may get something like this. Well, actually, it's just the loaded model from the obj file, and let me show how it looks like how it looks on the mobile device. So here we are, and okay, lift off. So I may just rotate it, as already implemented the rotation function. And well, yeah, sure. Instead of this head, you may place whatever you want. And also, yeah, it looks good, but not very well, as it doesn't. It's not. Oh, sorry, it doesn't have some textures. With textures, sure, it should looks a bit better. So here is the bind and the textures, which also easy as with previous example with just plain 2D instruction. So we just load the texture and just set it while we're creating the mesh, and we may get something like, I don't know. Let me see. Well, yeah, here's the screen. So yeah, something like this. Still, again, it runs on my device quite fast, not on this, unfortunately. And in this way, you may load any 3D model you want, just bound some engine, physical engine, and make some maybe not very complex, but still 3D game if you want. And probably it's all the abstractions and helpers the plain Kiwi provides for you. But also, just for fun, I just began to, doing something like port of the 3JS, if you know this library, the JavaScript library, to the Kiwi, and I called it Kiwi 3. And here, or there, I provide some more abstractions like camera, scene, render, so all the stuff you usually need for high-level creation of the 3D applications. Well, and also as my theme is general, about the graphical application which may be used with Python, I should also mention about some other projects like, for example, Ignifuga, or I hope that I pronounce the name of this framework in the right way. So it's also the engine for creating the game. It's written on the Python and Cython as well as the Kiwi, but it's based on the SDL, and it doesn't provide you the raw OpenGL wrappers or just functions you may use directly. And well, it has all the advantages and disadvantages for 3D, for example, programming, as the SDL has, as it's based on it. And also, here's the Panda 3D, very well-known engine. And yes, they really claim that it may be built for Android and iOS, and may just create some application with using of this framework. But first of all, I tried it as quite non-trivial, and the second point is that it's quite heavy after compilation. It may take about 100 megabytes. So for some simple 3D application, it may be quite heavy for Android application, obviously. Well, and that's all I have today. Thank you very much for attention, and yeah. Here's the GitHub repository. You may found the 4 demos I shown you today, and if someone have a question, you're just welcome to ask it.
If you have any questions, there's a mic right here in front.
Hey, thanks for coming and talking about Kiwi. That was a great introduction. I was curious if you knew about PyOpenGL and whether it's, I think I've read that it supports mobile platforms now, and I wonder if you could use it with Kivy to get the most complete possible OpenGL bindings.
Did you say PyOpenGL, right?
Yeah.
Yeah, sure. Look, for desktop, it's true. So you may place all the PyOpenGL functions inside of the callback, right? I mentioned in my presentation, and it will work. But the problem is here that it will not work for Android and iOS because well, PyOpenGL also provides just wrappers around the OpenGL function, obviously, and it's quite complicated because I think that it's based on the C types to port it for Android and iOS. Well, if it will be done once, you may also use the PyOpenGL for it, but right now, Kivy functions, OpenGL functions works just fine.
Thank you.
You're welcome.
Hey, Niko.
Hey.
I had a question about the compatibility of writing Kivy code. So if I were, and I'm sorry if you covered this already, but if I wrote code to be used with Kivy, intending to deploy it on Android, what sort of compatibility would I have if I also wanted to deploy to iOS? Does Kivy sort of abstract the code away from what it's running on, so I could compile to APK and deploy that? And
well, sorry. Let me just ask again. Do I understand you right? So if you write the Python code, right, like may it be run without the problems of both Android and iOS platforms? Is it right?
Yeah, right.
Yes, sure. If you use only the Kivy stuff, yes, it's not the problem. The same Python code may be run on both Android and iOS platform without any problem, as the Kivy itself cares about it, and it provides you, the cross-platform implementation of this function you use. But if you will use something more specific, like your own library, which is written on Python with using some more platform-specific code, well, it may not work. So you should be careful about it. But yeah, in general, if you use the Python code, pure Python code, with using the Kivy libraries or some other libraries which is supported by the Kivy project, it's not a problem. It runs well on both platforms.
Great, thank you.
Yeah, thank you too.
So I have some code that I've written and I want to run on Android, but I don't want to do anything related to graphics. Supposedly Python for Android allows you to do such things, but I do not see any way to connect up Java code to do the typical Android style of UI for it. Do you know anything about that? Is that something you're familiar with?
Sorry, what the problem is that?
Running the Python code from Java control code via Python for Android, is that something you know about at all?
So running the Java code from Python or vice versa?
No, without Kivy. Running
without Kivy? Well, it's possible, but it's more complicated because you need probably really, patch the Java runner on the Android, because it uses more the Kivy stuff. Well, in general, it just runs your main.py file, which may not call some Kivy application and may work like the process with Python. But anyway, you need to interact somehow with the display. Yeah, so for non-graphical application, it may be okay. But anyway, still you need to access the Android API for network and so on and so on. And yes, but for graphics, it creates the SDL surface view, and all other things is drawn here. It's like it's implemented for Android, something like this. Yeah. Okay, I see that no more questions.
Great. Well,
Yeah.
Niko?